There's nothing
There's
wrong
priorities, right?
Hi, everyone. This is Dr. Vishal Sharma of the tech-a-tete Group and Principal at Metanoia Inc. coming to you with another CE Live that you've been hearing about on the group and through the various emails that you've received. And I'm very delighted to have today both Ralph Santitoro and John Kieffer of Fujitsu. And Ralph, as many of you know, is a distinguished MEF fellow. He's also the co-chair of the marketing committee. And I've invited both Ralph and John to be with us today to share an excellent white paper that they've written on the new service definitions and bandwidth profiles that have come out from the MEF with MEF 6.2. So Ralph and John, let me start by welcoming both of you. And you can take a minute to maybe tell us how the white paper came about before I dive into sort of the summary of the news that I tend to bring in these sessions.
I guess it was, well, Ralph and I are both involved as MEF ATPs and writing material for MEF CECP certification. And as I started looking at the new requirements for 6.2 with bandwidth profiles, I said, wow, that's interesting. And it's not trivial to explain or wrap your head around. So I thought, I proposed to Ralph, would this be a white paper? And you like the idea?
Yeah, and the same thing, we a lot of times when the MEF comes out with new specs, we have, lots of questions, either just from customers or just questions from anybody in general. And because the bandwidth profiles are so different, there's such a big change in MEF 6.2 from 6.1, we felt it would be good to have have a document that basically explains, what the differences are and how they work. And actually it was kind of out of convenience because we kept getting asked the question a lot, and we figured let's go write a paper, and now we could read the paper and then then follow up with more detailed questions.
No, I think that's fantastic, and I want to make sure I tell people here, that the Fujitsu folks have been absolutely fantastic in all of the MEF-related literature that you've produced over the years. Starting with the guide for the CECP, and then John's book on Carrier Ethernet, which we spoke about in the group a few months back. And of course, Ralph, we're all familiar with a lot of your white papers and publications, and we've all had an opportunity to read that, starting with, the data center stuff that began 2-3 years ago in the MEF and, clarifying that. So, I'm pretty sure that a lot of folks who are viewing this online or may view it later were very familiar with your work and excellent things coming out of Fujitsu. So today, again, just to set the stage, the objective was, as you rightly pointed out, this is, there are subtleties in the changes that have happened. And the white paper, I think personally, is an excellent idea, because before you dive into the real standards, it's always better to have the opportunity to see what the big changes are, and then you can always read the details. So, and it's great that you have both taken the time to come and talk to us about it and give everybody on the group and even others outside of the group a view. It's a real treat to be able to have the authors themselves come and explain something to you. So that's what we are looking to do. Now, what I wanted to start with is I just want to take about 10 minutes to quickly cover a few of the topics, as I told you earlier, that have come in the group. Let me start by doing a screen share and showing people the mind map that I've created, which actually summarizes a lot of the developments in the group. So let me just do that. And you may or may not be aware of it, but what I've been doing the last several CE Lives is that I create a mind map that I can then share with people. It's a clickable mind map. It's actually already linked from the announcement of the CE Live. Let me just bring it up. So can you see that, Ralph? And
yes,
Tom?
yeah, we can see it.
Okay, fantastic. So guys, this is for everybody who's attending and who's viewing it later. This is what a mind map looks like of all the topics in the week. And there's a lot of detail here, but as you see, it's organized by categories. Obviously, SDN NFV is huge. We also talk about Carrier Ethernet and how that's moving towards virtualization. Wireless and video are always there. This time, there was a lot of focus on broadband for obvious reasons. June 12th was the deadline for the FCC's Title II regulations to come into effect. And then there's always industry news and commentary. And then lately, I was trying to acknowledge everybody that's been active in the group as contributors in my update, but that has a limit of 4,000 characters. So I began to give the list of contributors here because we have 130 contributors of various types. So I just wanted to let people know that this list is here everyone's acknowledged, and a lot of people have heard personally from me thanking them for their contributions. And that's really what makes the group going. So just wanted to point that out. And what I'm trying to show you here is that you should make use of the mind map. I'm going to cover some very selective topics here very quickly to give you guys a feel of what is actually here. There's some excellent writing from Tom Knoll, a lot of different interviews that were presented by some of the folks at IIR. Many of you them have contributed stuff in terms of either questions or topics that are of relevance. And so the way this is structured is, the important topics are in blue, and then subtopics, which I think are interesting, are all color highlighted. So you guys can, go and take a look at least those topics, which I think are important to be abreast of the industry goings on. And then if you click on that further, there's a short link, and sometimes there are references. So for example, for P4, which I'm going to talk a little bit about, I provided a lot of good references of the seminal papers that got this initiative going and so forth. So when you open this, you're viewing it in your browser later on, you'll see a lot of references that are going to be there. So let me start by talking about a couple things that have been going on in the industry. And what I really wanted to emphasize was the SDN data plane. And there are a couple of topics that deal with the SDN data plane here. Let me just point those out. It's right here. There's P4, and there are some presentations on server and processor architectures and how they've changed over the years that you probably want to look at. So I'm going to do away with the screen share so I can kind of address everyone here. And I'm going to be consulting my notes, so you'll find me looking down. So please don't get too disturbed by that, because I'm trying to give you the best information I can. So the deal with SDN data planes is that we have lot of focus has been on the control plane and orchestration, and obviously those are northbound APIs. The MEF's talking about it, other bodies are talking about it, and the ONF and so forth. But the fact of the matter, which I want to emphasize here, is that the data plane is extremely important as well. And even though we talk about going to generic hardware, I don't think people should recognize that not everything can be done in necessarily COTS-based hardware. So there is going to be a class of server processors and network processors that are required to do the additional work that is required when you go to an SDN-based network. I mean, the definition of what constitutes a flow, even when you're doing open flow-based control, has changed. The number of fields you need to look at has expanded. And not all of it can be done in standard processors, even today at line rate. So there is a class of processors coming out from Cavium, Broadcom, Barefoot Networks is now working on it, Accelerated, which is now part of Cavium, which are actually creating a lot of IP in hardware. So I just wanted to bring this point up because this often gets lost and people might think there's no innovation in hardware possible, but there really is. And here's the reason why. So what is happening is that with the change in the way we are building networks and with virtualization and even SDN NFV, compute has to shoulder a lot of network workloads because things are a lot more distributed. You got a lot more virtual machines that are handling your workloads. And you have higher demands on scalability, on latency, and I/O bandwidths. As a result, you need to create server and processors that are optimized for this new class of workloads. And that's what the Caviums of the world are doing. And there are a couple of discussions here that are linked, which was an excellent presentation done by Cavium and Freescale at IEEE ComSoc event here in Silicon Valley. And those presentations are available. But basically what they're saying is that because of these new requirements, there are certain things that you have to think about when you try to do virtual network functions. One is that the virtual network functions require to process higher amounts of traffic than your typical IT virtual machines do. That's, I'm going to point out 3 things because of which you need to think about hardware design in a different way. So as a result, today, if you just put your new communication workloads on standard VMs, you only get about 50 to 60% of the performance that you get with a physical network function. So that's not good. So therefore, you need innovative NFV servers or specialized NICs that are going to offload processing off the server in your data center so that you can handle these new demands. The second is that the virtual network functions are unable to use hardware look-aside accelerators that are common, that have been common in hardware design. And so you have to think about how you can provide hardware acceleration for the various functions that you need while keeping the HC NFV and the OP NFV sort of architectural specifications and standardizations in mind. So therefore, you need to standardize accelerators for a number of functions so that your VNFs can work well. And finally, the physical network functions use control and data paths, and they tend to implement data paths in special types of processing systems, FPGAs, ASICs, multi-core processors, and so on. And not all of those are necessarily available, off the shelf in today's virtual machines. So if you really need to build OpenFlow-enabled packet processing cores that keep the NFV principles of separation and VNF managers and infrastructure managers in mind, and at the same time can provide you the acceleration that you need. All right. So that's the reason for looking at the SDN data plane. Then the other thing I wanted to point out is that there's an initiative called the Open Data Plane by folks at Linaro, which is essentially the idea that you open source an API to the networking processor. And the idea is that you become agnostic to whether you're using Broadcom or Freescale or Intel or Cavium or any other processor, or whether you're using a MIPS core or an ARM core or PowerPC or x86. But you want to be able to just program that core in an independent fashion. So the applications can be ported across different cores, and it doesn't matter what kind of virtual machine you're on, what kind of server architecture you're on. So I would encourage you to check that out. I've provided some links in my mind map that take you to the Linaro Foundation, which is actually an industry group that was founded about a year and a half ago. And just this March, they've come out with their first specification. And they also have a very nice white paper. In fact, let me actually do a screen share and show you guys what I'm talking about, so you know what it's all going to look like. So here you see, this is the white paper from the Open Data Plane .org, which is really part of the Open Data Plane Foundation. And they talk about why you need an open data plane and how they are thinking about designing it. And the first release of the Open Data Plane architecture, as well as the software, is just come out, as I said, literally a couple months back. So this is really technology development hot off the press, and it's happening today. So for those people who are looking at diving into these technologies, this is right about the best time to do that. So that's what I needed to say about that. The other interesting development in SDN has been the P4 programming language. Some of you might have already heard about it. Jennifer Expert at Princeton, Nick McKeown at Stanford, and the team at Barefoot Networks. They published a seminal paper in SIGCOMM just last year. So again, very, very new, called Programming Protocol Independent Packet Processors. And this is essentially the idea of developing, if you will, an OpenFlow 2.0, where you're not just programming, low hardware tables inside of a switch in the data path. You're actually developing, again, an intermediate language that you can use to program all manner of switches. And you don't really care how the hardware tables, the so-called match action tables, are actually implemented at the lower levels. And this is, I think, a game-changing development. It's in the very early stages. They just founded, again, a foundation called p4.org. It has a very jazzy new website, and everything on it is free. Their first, open source version of the P4 programming language code is available, and they're encouraging people to join the initiative so you can help in A, developing the programming language, and B, in finding use cases for it. And very quickly, I want to share two critical insights that Jennifer shared with me, at the last concluded Open Networking Foundation, which she found, two uses of P4 which they hadn't, contemplated. One is that the chip manufacturers would actually want to use P4 so that they don't have to expose too many of their details, to anybody above them, so they can keep a secret sauce. The system vendors want to use P4 as a way of specifying their requirements to the chip guys, like the Broadcoms and the Caviums, so that the system vendors don't give away the secret sauce. You are just telling them what functionality you need, and you're doing that in a programming language format. So you don't have to tell them too much about the secret sauce that your system is actually going to have. So this is something the P4 team, Nick, Jen, etc., hadn't anticipated when they started out with this initiative. The second thing that she told me is that it's becoming, so both the vendors and the hardware guys are finding value in P4 for quite different reasons, which they hadn't thought about. All right. So this is something that I think is going to be a very active development. They just had the first workshop on P4, and they're going to have more of these both on the East Coast and West Coast. So this is something you want to look out for. So let me jump to the next thing I want to talk about is broadband developments. I've already talked about this in several previous events. Basically, the idea is that the FCC back in February reclassified broadband, saying that we need broadband is 25 megabit per second download, 3 megabits per second upload. What they basically did is shed light on the broadband in the US, where 55 million Americans all of a sudden no longer have broadband because they don't have these speeds. So this is something that actually forces the broadband providers to think long, deep, and hard about what they're doing. That at least is the goal of the FCC. The other thing I wanted to point out is that not all broadband needs to happen from sort of the commercial market. There's a link to in the mind map about called the Tale of Two Cities. In the broadband branch of the mind map, where they talk about, it's a beautiful article, and I want to highlight that, where government actually made a difference. One is an example of Stockholm, which publicly funded its fiber rollout 20 years back, and today the status is that 90% of the homes and 100% of the businesses in Stockholm have a 100 Mbps connection, and the price of that connection in Stockholm relative to New York City is 1/4. So you're paying 4 times as much in New York City in today's day and age. That's an important thing to remember. And the other city that has done that in the US is Leverett, Mass. What they've done is they've laid out fiber inside of a 2,000 person town operation by funding it through $3.6 million in publicly funded. They only had to connect the town of Leverett. And Massachusetts, in the last 3 years, has built out a middle mile network at a cost of about $90 million, funded partly from the state and partly from the federal, Connect America and Act. And as a result, the town of Leverett can then just simply plug into what's called the Mass Broadband 123 network. And that provides total fiber connectivity in this town of 2,000, going all the way back for backhauling. And this is important to point out because this is an example where, which have usually so far were successful in actually implementing, broadband. So again, something for the practitioners among us to think about, that there are possibilities, even with bloated government to make things happen. And by the same token, one important thing I want to point out, which happened in the city of Austin, is that Google Fiber has this special treatment that when they get to a city, unlike many providers, they're allowed to pick and choose the neighborhoods where they are going to deploy broadband. And so they can choose fiber hoods to build their fiber out, and they have permission to do that. Now, in the city of Austin, what happened is AT&T requested the city to give them the same treatment. And there's an article in the mind map that talks about this. And what they were able to do is they were able to choose their neighborhoods and roll out their broadband fiber deployment actually earlier than Google could. And this turned out to be advantageous for AT&T because they were not saddled with the capex costs of having to roll out broadband all across the entire city of Austin. And this is important to note because this kind of levels the playing field between the OTT operators like Google and sort of the more incumbents like the AT&Ts and the Verizons. All right. And the last topic I want to talk about is video traffic, which is multiplying. Report is out, and they're saying that IP traffic between 2014 and 2019 is going to triple. And video traffic, which is today 67% of all IP traffic, is going to become 80% of all IP traffic. And an interesting takeaway for all of you guys is that in 32 years, between 1984 and 2016, it was the amount of time it took for annual IP traffic all over the globe to reach a zettabyte, which is 10 to the power 21, right? 1 sextillion, if you will. And in the next 3 years, between 2016 and 2019, we're going to add on 1 more zettabyte to the 1 zettabyte that we're about to be at in about 6 months' time. So what took 30 years to get to is going to be accomplished in 3. That's the pace at which stuff is growing, and video traffic is key. And one thing for video traffic is bandwidth profiling. If you don't have your video traffic ain't worth squat. So that brings me to Ralph and John, and that's why they're here today, so that we can understand what are the changes in the bandwidth profiles that the MEF is making. Maybe start talking about what the motivation was, and then of course John has been kind enough. He's going to do us a deep dive, and I'd urge you all to pay attention. If you have questions, guys, I know there are a lot of viewers. I see about 12+ viewers on the show. Then please post it under either the discussion that John initiated called Understanding Bandwidth Profiles, or better yet, post it, let me tell you exactly where, on the discussion that I started for this CE Live. So let me quickly show you that so that it's clear where you want to post your questions. All right, so guys, this is where, this is the discussion on which I'd like you to post any questions you have. All right, so that they're all in one place and we can take them as we go in the broadcast. All right, so John and Ralph, I'm going to hand over stuff to you. Maybe, as I said, you already gave us a bit of a clue about what the white paper was motivated by. Maybe you can start by telling us, what the whole change in profiles was motivated by, and then we can do a deep dive.
Right. Well, okay. I have a little PowerPoint presentation that we made for other reasons, and I think that it's like an introduction to the paper, so it kind of addresses that. It goes right after that. So let's just go to that PowerPoint presentation. Okay with you?
Wonderful. Yeah, that'd be fantastic. I think that's
so
all.
If I share my screen, it will show up?
Yeah, if you just do your screen share, and it'll show up in about a few seconds after you've pressed that button.
Oh. Okay.
Yeah, great. We see it.
You've got it. Okay. Let me bring that up. Okay.
And John, just one quick point. In the screen share, you want to select the option of present to everyone so that anybody else who's viewing it online can also see it.
Okay, I think everyone is seeing it. You can see it, right?
I can see it, yes, but I see it because I'm actually a presenter myself. So if you've done that option, that's great. It will everybody who's viewing it should be able to see it.
I don't know where that option is, Michelle.
Actually, when you do the screen share, it asks you, that a button comes up in gray which says present to everyone. And if that's not coming up, then you've chosen that option.
Maybe just select it again.
Screen share. Okay.
Just select it. Yeah, go select it again.
When you say screen share, then two buttons come up. One is a stop button and one says present to everyone.
Okay, I'm hitting screen share, and it just shows up.
Okay, okay, maybe because you got it.
Is somebody watching? Send a chat if you're not getting it.
Yeah, no, I'm getting it fine. Yeah, exactly. If somebody is not seeing it, please,
send a chat.
Post a comment on the LinkedIn group, and we'll address that. All right, so let's get started.
Okay, so the paper's on the MEF website, and when we get through this, I can show you where it is. But here are the motivations. Oh, wrong place. Okay, here we go. Okay, motivations for the paper are to explain the changes to bandwidth profiles between MEF 6.1 and 6.2. And there are three main changes. One is that the algorithm, the bandwidth profile algorithm itself, is generalized to support multiple flows and token sharing among those flows. The second one is that per uni bandwidth profiles and per EVC bandwidth profiles are no longer used. We'll get to that. And finally, the per class of service egress bandwidth profile has been replaced by the per EEC egress bandwidth profile, where EEC is a new definition for service frame classification at egress, similar to class of service, but independent of class of service. So those are the things that we'll try to explain in this, in the paper and in this short introduction to the paper. And really, it's for all technical professionals and MEF CECPs.
So John, one quick point. You mentioned that the two bandwidth profiles are no longer used. And I think this is a discussion I just wanted to kind of highlight here. Of course, you're going to talk about it later, is that the fact that they are no longer used does not mean that that functionality has been lost. It's just that it's become more granular, if I understood it right. And you can still accomplish the same, and code is going to have to do it differently. Right?
That's correct. That's correct. I think it's somewhat of a semantics thing, because there's nothing called a per class of a per uni bandwidth profile or a per EVC bandwidth profile anymore. But you can create a per uni or per EVC bandwidth profile, or a bandwidth profile that handles all of the frames associated with a uni or an EVC using this multiflow per class of service bandwidth profile.
Yeah, and I think
the other thought that comes to mind is that if vendors have implemented some of this in their CLIs or programming frameworks, they're going to have to go and make those changes as well if they're going to become, if they're going to follow the 6.2 specs now, because that terminology wouldn't really be useful anymore.
Well, actually, yeah, that's correct. The terminology per EVC and per uni bandwidth profile is not used, and yes, if they specifically had that coded in their CLI, yeah, that is correct. But functionally, you can achieve. I think that's the key point, is that you can functionally achieve what was called a per EVC or per uni bandwidth profile. I think the other thing to add to that is the MEF is developing Yang models right now for the MEF services, and so this new the Yang model will include a lot of this new terminology in there. And so the beauty of that is that if as those Yang models get completed and you incorporate those into your design, then you'll be able to basically you have your CLI or your element management system be able to pull out the information from the Yang model. So in the future, as the MEF introduces new Yang models, you don't have to hard code anything, because you'll be able to get that information from the model.
Okay, fantastic. Fantastic. That sounds like something very useful. So that's going to happen. That's happening right now. So is it like going to be done in maybe 6 months?
Yeah, the Yang models are being developed right now in a specification.
Okay, wonderful, wonderful, great. Thanks, Ralph.
Mm-hmm. Okay, so very quickly, I think most people are familiar with the 10.2 bandwidth profiles. There's 6 of them per EVC, per uni, and per class of service. And there's 6 of them because there's ingress and egress variants of those. And then in our 6.1 service specifications, the MEF adopted all 6 of those, and that's what everyone is familiar with. So what's happened here is in MEF 10.3, which supersedes and replaces 10.2, each of those bandwidth profiles has been generalized to be a multi-flow bandwidth profile. The algorithm is generalized. Okay, and one additional thing is that MEF 10.3 changed the per class of service ID egress bandwidth profile to this per EEC ID egress bandwidth profile. So there's a subtle change there. And then finally, MEF 6.2, which defines EVC services, only adopts the most granular of those bandwidth profiles that are defined in 10.3. So that's how the standards have changed. So
actually, in a sense, that's good. So we've reduced in 6.2, we're able to realize all of the services using just 2 of the profiles by choosing the most granular ones, as opposed to having a whole family of profiles as we did in 6.1.
That's correct. So okay. Just to review the 6.1 conceptually, the bandwidth profile algorithm, what it does is process a flow of frames, and colors, and the algorithm colors them green, yellow, or red. And the bandwidth profile parameters you can think of as the settings for a machine that implements the bandwidth profile algorithm. So that's why I've made this little image here, and the control dials are CIR, CBS, EIR, EBS and a couple of switches, coupling flag and color mode switches. So those are the switches that you can set for your bandwidth profile. And then once those switches are set, it implements a specific case of a bandwidth profile algorithm, which is that dual bucket, token bucket algorithm that I think most of us are familiar with, a green bucket and a yellow bucket. So also at the in the 6.1, we had, as I mentioned before, we have per uni bandwidth profile, which captures all frames coming from the uni, however many EVCs and class of services are at that uni, and processes them with one flow, one bandwidth profile. Or you could have a per EVC bandwidth profile, which captures all in one flow across one EVC, or a per class of service bandwidth profile.
Sure.
So, and these at ingress or egress. So that's what we have. What does it change to? Now with MEF 10.3, that bandwidth profile is generalized to support multiple flows. So what does that mean? It's roughly conceptualize it as the previous modules, single flow bandwidth profiles, like a stack of them, but there's going to be interaction between them in the stack. And,
sure.
And there's a couple more dials on each one of those modules. There's a CIR max and EIR max dial, and there's an overall system coupling flag. So it's just a much more sophisticated bandwidth profile.
Actually, I wanted to acknowledge here the contribution of one of my good friends and colleagues, I think Shahram Davari of Broadcom, because I think a lot of the, if I'm not mistaken, a lot of the ideas that led to these changes were contributed by Shahram, if I recall right from the various discussions that happened before this was all finalized.
Okay. So to explain the algorithm, this is the image of the algorithm. Let's just go through. Oh, first of all, just to make the points that the flows in this algorithm are ranked, and the topmost one in the image has the highest priority, and unused tokens are going to be flowing downward in this image.
Sure.
Or they'll flow from left to right, from green to yellow. They'll be demoted from green to yellow, unused tokens.
Sure.
Okay, so the algorithm works like this. Imagine that you have a stack of the previous 10.2 algorithms, and they're all operating independently. The problem with that is that unused tokens from the yellow bucket will just be discarded. Overflow from the yellow buckets will be discarded, and overflow from the green, if the coupling flag is set to 0, will be discarded. So the first image you need to have in your mind is those things won't be discarded anymore. There's a potential for token sharing because there's sort of new paths introduced by the algorithm where those overflow from the yellow bucket will now go down to the next module, or can go down to the next module, depending on how the settings are. Same
Sure.
with the green bucket. And it goes from all the way down through. The second change is the introduction of new rate limiters. And in this figure, I've chosen to use a funnel to represent these rate limiters, EIR max and CIR max. The image is a little small, so let's just blow it up a little bit and talk about it. So you got more tokens flowing into the green bucket from your CIR setting, but also potentially from the module above.
Sure.
And so the rate limiter, it doesn't store tokens and it doesn't discard tokens. It just says if the sum of the stuff coming into the green bucket exceeds the CIR max limit, then we're just going to direct the excess to be combined with the token bucket overflow and go wherever that goes. And the same with the yellow bucket.
All right.
So I understand the purpose of this is it kind of helps to ensure that the lower flows you can use it to help ensure that the lower flows are not starved if the upper flows have plenty of tokens.
Sure, exactly. And then I noticed here, John, that that there is a flow of tokens that can happen left, right also. Yes, you did point that out on the previous slide. Got it. So
Yes.
you can actually flow from green to yellow.
So those are the two main things. And so now let's talk about that that system-wide coupling flag at the bottom. That's kind of interesting. If that switch is set to 0, then it pretty much works as I've just described it so far. You have all these coupling flag options here where you can have green overflow go into yellow at a module level.
When it's set to 1.
But when it's set to 1, or if it's set to 0, it goes down. And anyway, so tokens generally go down or possibly yellow and then down. But in the end, after the bottom flow, if there's unused tokens, they're discarded.
Sure.
Now, if you set the coupling flag equal to 1,
Coupling flag to 0. Yeah.
the coupling flag 0 to 1, then what it does is those tokens that are overflowing from the bottom green bucket are no longer discarded, but they're rerouted upwards to flow into the top yellow bucket.
Ah, okay.
And in addition to that, there's something, notice that all those paths that were between green and yellow have been removed, because when you set coupling flag 0 to 1, a requirement is that the other coupling flags, the modular level coupling flags, have to be set to 0. So in other words, that opportunity you had to go from green to yellow at a modular within each module is no longer there when you set coupling flag to 0. So it just goes strictly, the path goes strictly down through the greens, then up, and then down through all the yellows.
And so the idea here is that if you use the global coupling flag, you're either recirculating all of the balanced tokens into the yellows and then letting them flow down in the order of priority. That's one way of doing it. And the other case, you're coupling individually at these specific levels, and you're allowing for some flow between the green and the yellow at that level. So that's kind of the trade-off. And so between the two approaches, right?
Right. So that system-wide coupling flag has quite an interesting effect. Okay, so let's talk about why per uni and per EVC bandwidth profiles are no longer used. In MEF 6.1, they were used, but the bandwidth profile could only support one flow. So if you had a per uni bandwidth profile, all of the frames across the uni are going to be processed by the bandwidth profile non-discriminately. In other words, there's no class of service awareness, no EVC awareness. And the same with the per EVC bandwidth profile. It's going to be processed. If there's classes of service within that EVC, they'll all be processed non-discriminately.
Yes.
No awareness of class of service. So with the new bandwidth profiles, if you want to implement a per uni bandwidth profile, you can certainly do that. But the way you do it is you take all of your class of service flows across the per uni and map them onto one multi-flow bandwidth profile. It's still only one bandwidth profile. You can think of it as one allotment of bandwidth, but now for the whole uni, which is shared among all flows in the uni. But now it's shared in a way that's a little bit more. It's aware of class of service, and so it can be shared a little bit more strategic way. And the same with at the EVC level, you can take all the classes of service that flows from an EVC and put them through a multi-flow bandwidth profile. So you can have prioritized per class of service processing. Now,
So this kind of reminds me of John, just if we stay on this figure for a quick minute, this kind of reminds me of doing top-down versus bottom-up. I mean, in this case, we are composing, in 6.2, we've gone down to the lowest level of granularity, and we're composing a profile based on those profiles. Whereas in 6.1, it was top-down. So if you did it at the uni level, you didn't really, you couldn't really do anything more at the level of granularity beyond that. And same at the EVC level. But in 6.2, as you said, you can compose up, and because of the sharing algorithm that you were just talking about, you can even share that bandwidth between flows more equitably.
Yeah, and I think the other way to think about this too, if you think about it from a software development perspective or programmatically, rather than if you think of the per uni and per EVC, and then you had per cost ID, you had 3 bandwidth profiles. So that means when you're instrumenting your CLI or EMS or your GUIs, whatever, you had to do 3 things, right? But now with the per cost ID, with 1 bandwidth profile, you can do all 3. And so just from a development perspective, developing your product, you can achieve the same functionality, but now, and it makes it easier to model because now you have the most granular, and which you can always become less granular if you wish. So this is kind of moving in the direction we're having, kind of predefined, per uni and per EVC is moving away. So you can see the benefit of doing it with just per cost ID.
Absolutely, but there is one small point to be made, however, that the deciding of the coupling flags and how you're going to choose them, which ones are off, which ones are on. There's a lot of options there, and I don't know if there's some guidelines being provided as to what kind of coupling makes sense in what kinds of scenarios, or the network architects they kind of have to figure it out. I wonder what the MEF is doing in that department.
I think that the specs themselves are a little bit silent on that matter, although there are some use cases at the end of MEF 10.3 in the appendix there that are worth looking at. But I think it's kind of like opening up the door and new possibilities, and for different people it may mean different things.
Got it.
Here's an example of something that you couldn't do before. This is just to illustrate I want to make 2 points here. One is that across the uni, you can have any number of bandwidth profiles, and you can have any number of multi-flow bandwidth profiles and any number of single flow bandwidth profiles.
Sure.
And this example just shows one with 1 multi-flow bandwidth profile and one with 1 single flow bandwidth profile. And secondly, the standards now allow class of service flows across the whole uni, regardless of which EVC they're in, to map onto the same multi-flow bandwidth profile if you want. That may or may not make excellent sense. But all those frames belong to one customer. So it's not like you'd be mixing frames from different customers. But it's a new opportunity.
It would be odd to mix frames from different EVCs, though. I mean, you could if you really wanted to optimize, bandwidth sharing for whatever reason, but you probably had different EVCs for a reason to start with, and probably don't want to mix, across EVCs.
Well, yeah. So I think one of the benefits you get with this new bandwidth profile is work conserving, meaning that you have a much more efficient use of your bandwidth from a subscriber perspective, right? Where when you had individual bandwidth profiles before, you could share tokens from the green bucket to the yellow bucket when your coupling flag was set to 1. But with this one now, you can take those green tokens, which are subject to the SLA, and share those with other. If you look at each of the machines here, you can share it, as you go down. And so that allows you, those green tokens are subject to the SLA, and rather than them just getting lost or getting dumped into a yellow bucket, which is not subject to the SLA, you're actually getting a better quality or a better utilized service in terms of bandwidth. So the subscriber is actually, if a service provider implements this, the subscriber's getting a huge benefit, additional bandwidth benefit that they would not have gotten. So you could think of service providers using this almost as a differentiator for their service. You would get better performance or better bandwidth utilization if a service provider offered this versus if they didn't.
True. No, I think that's a fantastic. That's a very good point, Ralph. That you definitely have a lot of ability to do work conserving bandwidth sharing, which wasn't possible when they were segmented. And
So-
I think that's a big benefit for the operator too, because all said and done, yeah, we have a lot of, but we know that, as we just discussed, bandwidth is growing like crazy. And even though you can keep expanding capacity, there is a point at which you want to use what you have as effectively as possible.
So, and there's nothing stopping you from implementing a whole bunch of single flow bandwidth profiles, just like you could in 6.1.
Sure.
The thing is that you just be aware that any bandwidth that's unused from that flow is going to be wasted. Whereas if you do it with a multiflow, of course, there's an opportunity for unused bandwidth to trickle down to other flows. So that's the main advantage. I don't know how we're doing on time.
We are good. We have another 10-15 minutes actually. So
okay, then let's talk a little bit about class of service in this EC equivalency class, this new classification for service frames. Just recall how class of service is used before in 6.1 and 10.2. You map class of service ID is assigned to a service frame based on different things. It could be based on the EVC it's in, or based on PCP bits, or diff serve code point bits, or layer 2 control protocol. But anyway, in using whatever scheme is designed for the service, at the ingress unit, it would be mapped to a class of service ID, and then that class of service ID could potentially be used for 3 purposes. If you had per class of service ID ingress bandwidth profiles, it would be used for ingress bandwidth profile processing. And definitely it would be used for quality of service treatment through the SEN. And if there was an egress bandwidth profile per class of service egress bandwidth profile anyway, it would be used for that too.
Sure.
So for in the new system, the class of service ID is used in the same way for the first 2 purposes. At ingress, the service frame maps to class of service ID, and that determines which ingress bandwidth profile flow it's associated with in its ingress bandwidth profile processing, and it determines its class of quality of service treatment in the SEN. But now, at egress, there's a different mechanism, EEC ID, and it's also mapped, has the same kind of mechanisms mapped based on PCP bits, diff serve code points, or layer 2 control protocol, etc. Anyway, it's independent of class of service. It may be mapped from the same set of bits, but it's independent of the class of service. Anyway, and that is used only to determine which egress bandwidth profile flow it belongs to and how it's processed by an egress bandwidth profile, if there is an egress bandwidth profile on there.
So going back,
yep.
Going back to if you just go to the so when we have that that machine that you showed, through which the multi-flow traffic management machine, instead of using class of service at the egress, use the EEC. Is that the key difference? That you're going to remap from the same set of bits, you're going to derive an EEC value, and as opposed to the class of service, it's the EEC that's now acting, doing the same role as class of service was doing in the ingress machine?
Yes.
Okay.
So this figure addresses that very point here. It's talking through. Imagine a frame going from left to right, from ingress to egress. So it's coming in. It somehow class of service is identified with it, and that maps it onto one of the per class of service bandwidth profile flows, one of the modules of the multi-flow bandwidth profile here, shown here. And through there is not discarded, then it will go through the SEN with the quality of service treatment appropriate. Latency, for high class of service would be a lot lower than, say, for the other class of service. So, but then when it gets to the egress uni, we forget about class of service for the purpose of egress bandwidth profiling. We go ahead and re-identify now what is the EEC ID, and then use that to map it onto EEC ID flow, and that determines its egress bandwidth profile processing. So just to go through it one more time, you can think of it as the service frame. Let's say we're using PCP bits to encode both class of service and EEC ID. So we can think of in the before ingress, that information is already encoded in the service frame. Then when it gets to the ingress uni, that PCP bits are used to decode class of service ID, and that's used to assign it to a bandwidth profile flow and determine that processing at ingress, and also to determine its class of service treatment, quality of service treatment as it goes through. But then when it gets through the egress uni, then we go and look at the service frame again and look at the PCP bits, if that's what we're using for EEC ID, and decode EEC ID from that. And that is what's used to determine which egress bandwidth profile, how it's processed by egress bandwidth processing, if there is an egress bandwidth profile. So kind of confusing, but I hope it, you got to think about it a little bit. And
so John, I mean, the mechanics are clear. I guess one of the questions that I have, and again, we may not answer it right away because there may be no one straight answer, is kind of the motivation for doing this. I mean, to me, it seems that it would be more helpful in an NNI scenario, right? You can imagine that you started off at one end of the SEN, classified with a certain class of servers and a certain treatment. And at the egress, based on the agreement with my adjacent operator, I may use EEC, reclassify things, and then put them out in a way that the adjacent operator is expecting it or whatever. So that would make, I can think of an application there. When I'm sending it to essentially my customer network, it's a little bit harder to visualize, what exact value is being provided by doing a reclassification and then using the EEC to do the egress bandwidth profile.
The MEF specs themselves are silent about that, as far as I know, and so I don't have any special insight into it other than speculation. But if you'd like, I can make one little speculation, and that is, it might just be to clarify the meaning of class of service ID. Even before this change was made, this is the way I believe it was intended to work, is that you remember you have different maps you can potentially have different maps for class of service ID at different unis. So,
sure.
It's very, if you only have one name, class of service, then it's very tempting to think that once class of service is assigned at ingress, it's going to persist with that frame all the way through. But even if you think about it, even with the old definitions, the intention was that you use, for egress purposes, you use the map at the egress uni, which is not necessarily the same at the map at the ingress uni.
Sure.
So from that perspective, it may be, from a practical point of view, EEC and cost of service, maybe the best policy is just to make them be the same thing. But
at least you have the flexibility to treat them separately, and also I think, as you said, there's a clear distinction that now wasn't so evident, in the earlier incarnations.
Yes. So now it's crystal clear that it's the map at the egress uni that applies. That's one big thing to me, and it opens up the doors to who knows what what creative things people may do with it.
Absolutely, absolutely.
Just to add to, just to add what John said, I think that rationale is very. I think that's a really good rationale for that. And then just wanted to resonate what you said, Vishal. When you do this at an E and an I, that's where it makes a lot of sense, because if you have two different operators, right, then that's where one operator has its cost ID policies, which more than likely will be different from their peering provider. So so as this evolves over time, I could see that. I mean, that's a very, very obvious use case, for an OVC. It's this is obviously talking about EDC, but as over time, that'll probably be a popular use case.
Yeah, and that's my thought. That's the thought that came to my mind. Of course, Ralph, the other issue is that it requires a certain amount of cooperation and give and take and openness between the two operators. But as we get to more complex apps and complex POS capabilities, that's something that needs to happen.
Mm-hmm. So you got a couple of use cases, I think, right?
No.
That's fine.
So that's it. That's the presentation. So summary, just remember multiple bandwidth profile or multi-flow bandwidth profiles with token sharing. Nothing called per uni or per EVC bandwidth profiles, but you can get that effect. And we've got the per EEC bandwidth profiles now it's at egress instead of per class of service egress bandwidth profiles.
And I just got something from Larry Samberg on Skype that I wanted to share. And I think Larry made a good point. Larry said that it also makes sense because class of service can be lost across the SEN at some point. So if you reclassify at the egress and use EEC, then that makes sense. He's saying, for example, that if the frame traverses a SEN that has only 2 classes, and it will come in 3 costs and then deliver 2 costs. So medium and high can both end up as high, but if you do a reclassification and egress, you kind of eliminated that problem. So maybe that's another very useful point to keep in mind, that if your class of service somehow got lost or misclassified in the SEN, you have the opportunity to correct that through the EEC.
Yes, that's a good point.
Mm-hmm.
So the paper itself, go to the MEF website, MEF.net, and go to Carrier Ethernet and navigate your way to white papers.
And I think in your in the actual post, you probably provided a direct link to the white paper, if I'm not mistaken.
You can get there that way too. And so this is it. You can just download it from there.
That's fantastic.
The white paper, this is what it looks like. It's 20 pages using a lot of the images you've just seen. So you can go through it casually, take your time, and make sense out of it for yourself.
No, and maybe there, as people begin to look at it, there'll be more questions now that there is at least explanation. This has been extremely helpful to have that the highlights done, and now people can dive into the details.
Yes.
So we have some people who are online. I just want to give people a chance. If anybody has any questions, Larry, of course, ping me on Skype. If there are others who are not on Skype, if you want to post a question on the CE group, then now would be the time to do it. I've checked. So far, I don't see any questions, but sometimes the questions don't come immediately. They may come after the fact, and we can always continue the discussion either on the actual John's post or the CE Live post if people have questions later on, and people probably need to dive into some of this and have questions. How is this paper? It was just recently released, or it's been a while?
I guess we're here. Yeah. Sort of, yeah.
Okay. So are there any questions, Vishal? Or just waiting to see if some show up?
Yeah, I don't see any at this point. But I had my question was, about the paper. How recently did you finish it, and has it been there for a while? I didn't see I forgot to notice the date on it when you flashed it.
Yeah, it's actually brand new. We just published it through the MEF. I guess it was last week, I think.
Oh, fantastic! So
I think it was the day it went up. I think it went on to that the LinkedIn group page.
Fantastic. So this is great. People are going to get. So this should be very relevant to people. They can view this in conjunction with the paper to get an explanation of some of the fine points that you just did for us. So that's fantastic. So yeah, I think I don't have any questions at this point. If things come up, and they typically come up subsequently, we'll link it to the group. Talk about it. We do we can do another follow-up session depending on interest and what people want to talk about. Hello? Looks like your video is frozen for me. John, Ralph? Okay, so while I wait for John and Ralph to come back, guys, let me just close off with one little point that I wanted to point out, which you should definitely look at, which is the article on in the mind map that talks about what new criteria operators are using to actually select vendors. And because of the change towards SDN and virtualization, the operators are having to reinvent themselves as technology and business strategists. That's what the role of the network architects is. And there are 5 different criteria that Stephen Saunders pointed out in the article that are used to select suppliers in this new world. And they are: 1, you need a supplier that supports open standards and virtualization. 2, you need supports for system integration capabilities, which is extremely critical because they are used to high-touch hand-holding so far. When you get into an open, disaggregated world where you're pulling pieces from software, hardware, different kind of vendors, you obviously need to have system integration. Ideally, it would be the vendor with their professional services who would do that. But my feeling personally is that this is a great opportunity in the industry for people with those kinds of system integration skills to actually jump in. And there's going to be a resurgence of system integrators in a new, brave new world of SDN, NFV, and virtualization, where we should see a whole new class of integrators that can do multi-vendor, multi-technology, multi-layer network integration. There's not a trend that's traditionally found in the traditional vendors because they don't do multi-vendor things. The other thing you need is, because of the advent of cloud-like capabilities, you need enterprise IT experience. Because you need vendors that have helped large enterprises build their data centers, because that's what the operators are looking to do. And funnily enough, you need network architects that can design network based on apps and services. So it turns out that the uptime may not be as important as the ability to roll out new services. So network architects might be measured on how quickly they can roll out services, the DevOps model, if you will, that we see at the Facebooks, Googles, and LinkedIns of the world, than the model of, hey, let's design a completely redundant, highly available, 99.999% reliable network. And finally, you might actually want to have vendors that don't have an install base. So vendors like the Dells may have an opportunity here because they don't have an installed base. They can be preferred because they are more motivated to help operators build out new cloud-based infrastructure than sort of the incumbents are. And if you go to the forums online, the whole industry is abuzz with, whether the established vendors are actually trying to drag their feet over these kinds of innovations, or they are supporting them, and there's opinions from all sides. So I just want to leave you that thought. And I lost Ralph and John, unfortunately, at the very last minute, but I did want to thank both Ralph and John from behalf of the group and myself for coming and talking with us and giving us this fantastic preview that we got to this bandwidth profile white paper and the changes therein. And then, the mind map, updated mind map, I'm going to put it up so you can use the same link as I've given in the Google Hangout page, as well as in the post on the LinkedIn group. You'll get a new mind map after this. So thank you again, everyone, for attending. I look forward to seeing you at the next CE Live. And as I always say, until next time, may the bits in your bytes and the bytes in your packets be profitable. I'll talk to you soon. Bye-bye.